Okay, so today we're going to talk about um, one extra concept in singly linked lists called wrapper classes or interface classes. This may have been something you saw in the book, and I've heard a couple questions about it, so I want to go through it real quickly. So just a reminder, linked lists consist of objects, which we call nodes. They can have a pointer to another object, and the instance contains some information, usually known as a payload, and it points to another node. Um, these are often used in cases where we don't know the size. So we had this example running through a couple of our previous sets of slides, where we had we created a string node, right? And the string node that we had contained a character and a pointer. That should actually be my string node. I made a couple typos here. And a constructor that took in a string and slowly chopped off the single character. We had a function that gives us the length, right, which is a recursive method that just tells us the length. If the next pointer isn't null, then it figures out its length and adds one. And maybe it had a sort method, which was static. So notice that the sort method was static, so that when we call it, if we go back over here into our main, right, we make a new string, and our instance type is a node, and we get its length, and that's a method that takes linear time. And if we want to sort it, we actually have to sort it back into, we have to do this sort of weird roundabout thing to be able to save the pointer. And that's because we have our pointer str is pointing to the head of the list, right? So HELLO, because our string was hello. Each one contains a single letter. And when we sort it, if we just sort it as it is, our string pointer originally would be pointing to H, right? And we would basically get rid of this little E. So here's a different version of the code where we store the sorted array pointer, right, a little bit differently. But what if instead of having in our main program, we had some sort of encapsulating object type, right? So here's an example where, again, we have our string node over here. It contains just the character and a pointer, right? And its constructor now only takes a character, right? It still has a static sort method, right? But now we've created a new method called myString that contains a pointer to the head, a pointer to the end, which we didn't save before. We weren't able to save that before. An integer that encapsulates the length, right? And our constructor now does all the work. Our constructor in myString rather than the constructor in the node, right? It creates the first node in the linked list and creates an end pointer to the end. It is able to save the length of the string, right? And then it goes through and constructs the linked list just like we did before. So here's what that data type looks like, right? We have a head pointer, all of the nodes that we had before, and we have our end pointer. I forgot to include it here, but it also has the length, right, which is 5. So when we use it, right, the big difference is now we're not talking directly to the node, right? We're talking to this interface class called myString. It already knows the length, so this call is now constant time instead of linear, and sort is no longer static. I don't have to do any weird stuff with it. I can sort it in place, and it looks the same. So then when I run the sorted version, right, our head is now pointing to the right place, and we're all happy. So the question is this any better than keeping basically a raw linked list, or should we have an encapsulation class? One's not better than another, right? Depending on what you're doing, you might want to have an interface class. Like if you want to keep the head and the tail around and some other statistics about the list that you don't necessarily have without running some function, might be easier to keep it around than to have to calculate it every time. But at the end of the day, they're basically the same thing, right? And you're pretty much going to have to write the same amount of code whether you use an interface class or not. It's just how much easier it is to work with one versus the other. Okay? So this sort of wraps up the singly linked list ideas. Our next topic is going to be on doubly linked lists, which you should have already read about in the book, but we'll talk about it in class next.